Damn, data structures are so hard. How will I ever understand this thing?
What's the matter, MJ? You sound worried.
I am trying to learn the Q data structure and it's really confusing.
Why fear when Peter is here? I'll simplify it for you in just a few minutes. Here we go. Can you give me any real-life example of Q?
Line at the ticket booth in theater.
Correct. Also queue at the reception of a crowded restaurant. And the queues of cars on a highway.
So what exactly is a queue?
Queue is simply a list of data elements, arranged in order of insertion. In this sequence we can add as well as remove elements or data. More technically, queue is non-primitive data structure of linear type. In queue the memory is allocated dynamically. The insertion and deletion of elements in a queue is performed by enqueue and dequeue operations respectively. Queue is a first-in first-out data structure, which means data elements cannot be inserted from the front end of the queue, like cutting a line.
What is the front of queue?
Consider a queue of 4 people. The first person at the start of the queue will be the front of the queue. Here the front will be the boy in blue jacket. A queue also has a rear. The element which enters the queue last is its rear.
So the old bald man will be the rear of this queue.
Correct.
And what are the enqueue and dequeue operations?
Insertion of element from the rear of the queue is performed by enqueue operation. Dequeue deletes the data item from front of the queue.
Oh, so how will this operations be implemented on a queue and data structure?
Let me give you an example. Let us consider a queue of integers implemented using array. The given queue contains 4 elements currently. Its max size n equals 7. The rear of queue is 4 and front equals 1. Let us insert another element 20 in the queue. We'll perform this by enqueue operation. Now how does enqueue operation work? First we check if the queue is already full. In which case new element can't be added. If there is space in queue, we insert an element using rear equals real plus 1. Now 20 is added to queue and rear becomes 5. Let us perform dequeue and remove 10. First we'll check if the queue is empty, in which case, there won't be element to dequeue. If not then we increment front by 1. Thus 10 is deleted now. Similarly we'll dequeue 50 and add another element 60. Now front is 3 and rear equals 6.
Oh, and how can we implement this queue using array?
This will the algorithm for it. First will be the insert function, this is for enqueue operation. Then the delete function, this will perform dequeue. Lastly, the display function displays all the elements of queue.
But why should queue be preferred over other data structures?
Let me tell you the advantages of queue. Queue can have infinite length, compared to arrays who have fixed lengths. Length of queue is only limited by available space. It can work with integers, floating point numbers, characters as well as booleans, thus multiple data types can be handled by queue. Queue takes less space than most of nonlinear data structures, hence it's faster and more efficient.
That's great. However, queue can't be flawless. It must have some disadvantages too.
Surely it does. Let me list them for you. Queue is not readily searchable. While looking for an element you have to start from end and go through and compare every element. It's time consuming. You cannot add a new element until all current elements are deleted from the queue, not even if it has free spaces. Also, queues are difficult to create, maintain and manipulate as they are mostly implemented using pointers.
Oh, now I get what queue is. But what are its applications?
They are used in round-robin algorithm to schedule CPU tasks. Call center's phone system works on queue too. It helps for a system to do multiprogramming. Queue concept is also used in hardware devices such as printer.
Gee, thanks Peter. Now I finally understand the concept of queue. Thanks for helping me.
Mention not, because that's what heroes do.
You're still here. It's over. Go home.